Back really quick to the warm-up. Okay, once again, the warm-up 49 is on the screen. Those of you that join us on live or on the video, make sure you copy that. Same practice as we did the whole week. Agenda is warm-up number 49, quadratic equations. And hopefully page 121 and 122 only. Your Nearpod code, copy this, CVVTN, CVVTN, CVVTN. All right? Then, your previous home play, just because there was a misunderstanding with code in the afternoon. I had you guys know Ms. Zamora, right? She gave out a code for the afternoon courses, and somehow some didn't get access. I don't know what happened with the code, so instead of turning in this right now, I'm extending it for the afternoon, so you guys can turn it in later. Yes? All right. Also, once again, our home play for tonight is page 121, 122. You can find that with a Nearpod code or in Canvas. However, what concept are we on right now? Quadratic equations, yes. So make sure you go to the module of quadratic equations, and you'll find it in there. Okay? All right. So your home play, the lesson from yesterday, we're going to continue on that. So go to that Cornell note. If you want to use the back part of that, because we're going to continue there. And our objective was I can solve and graph quadratic equations by completing the square and square roots. So you have this already. Yesterday we started and we talked about the Freire model of that. We talked about this one. We solved it 3 different ways. We went with this one for completing the square, then this one. Then we went to this one, is that correct? And then from there we went to this one, talking about this one that they had already skipped certain steps. And then we got to the quadratic formula. Yes? So, let's see if we remember. What is the quadratic formula? X equals minus B plus minus square root B squared minus 4AC over 2A. You alright, Abby, over there? Was she there? Yeah. Alright, thank you. Minus B plus minus square root B squared minus 4AC over 2A. Now, why did we need that? Because we went to the next problem. You guys have this one, is that correct? Yes, Mr. Q? Alright, so we're going to finish it off together. Here we go. So I said for this one we had 3 steps. Step number 1, it needed to be in standard form. Standard form, what does that look like? It looks like this. It looks like ax squared plus bx plus c equal to 0. So question, does that look like that? No, that means we need to add 15 to each side. So like that, we end up with 0 on this side, and this side is x squared plus 16x plus 15. Now, is it in standard form? Well, let's see. Ax squared plus bx plus c equal to 0. Does that look like this? Pretty much yes. Step 2, we need to identify A, B, and C. Well, by looking at it, tell your neighbor what A is. And B. And C. Does everybody see all 3 values? Yes? Alright, and the third step is to substitute and solve. So we need to write our quadratic formula. X equals minus B plus minus square root B squared minus 4AC over 2A. And you should have that by now, yes? Then we did x equals minus parentheses plus minus square root parentheses squared minus 4 parentheses parentheses over 2 parentheses. Oh my goodness, computer. Alright, so let's substitute values. Start with this one. What is this value? B and B. What is B? 16. 16 there, 16 there. What is this one right here? That one is A. As well as this one, what is A? An invisible 1, so it's 1 and 1. And lastly, this is 15. Alright, so let's simplify. We're going to finish this off. Here we go. X equals negative 16 plus minus, bless you, square root of 16 squared is 256. Negative 4 times 1 times 15, that's negative 60. And all that over 2 times 1, which is 2. Let's simplify. X equals negative 16 plus minus square root. What is 256 minus 60? 196, yes, over 2. We can still simplify it one more time before we write our two equations. Negative 16 plus minus, what is square root of 196? Bam, 14, let's go. Alright, now I'm going to write my two equations. X sub 1, look at it. I would write the whole thing, but except I would only do what? Plus, so it would be negative 16 plus 14 over 2. And for x sub 2, it would be what? Everything, but now with a minus 14 over 2. Alright, so what is this? Negative 2 over 2, which is negative 1. What is this? Negative 30 over 2, which is negative 15. Make sure you copy that and have that. Very good. Some of you are like, Mr. Q, I got this. Good. We're about to do some work problems. Let's go. Woo! Let's go. Alright. So my solutions here, x sub 1 is negative 1, x sub 2 is negative 15. And these probably are the easiest ones because all you need to remember is a quadratic formula and make sure it's in standard form so you can substitute A, B, and C into the formula. Okay? Alright, we got it? Alright, here we go. So, enough tomfoolery with those, and the rest are pretty much the same. You just identify A, B, and C, substitute those values into the quadratic formula, and so on and so forth. Alright, so before we get started with work problems, there's two common type of equations used. Here he goes. The first one is about distance that fall in feet over time. And that formula looks like this. D of t equals 16t squared. The second one is this one. Height in feet in time in seconds, where h of 0 is the initial height in feet. Which is that one? Copy those two, please. Distance. The word distance starts with the letter what? That means this is distance. That means that time is what? So that means this one is going to compensate for time. Do you see time on the other formula? Yes, right here, time in t seconds. That means we still have the time in here. However, now we have what? An initial height. Initial height of what? Which is this one. So that means when they're asking for a different height, that one would be this one right here. So what's the only thing that you see on those formulas that we haven't really talked about? The number. Where do we get that number from? Well, let me see here. Let me see if I can get... anyways. So 16, guys, is like this. So let's say I take my basketball and I spin it in my finger, on my finger. What keeps it there? Gravity. That is correct. Here it goes again. Whoop, whoop, whoop. Anyways, you get the point. The earth is just like the basketball. That's why we don't fall off the earth, right? It's not like if I trip and I fall and all of a sudden I go flying. You see what I'm saying? What keeps us there? The gravity of the turn of the basketball, of the earth. So let's see. Here's Andy. And if he falls, if this stops turning, where does he go? That's why Earth has to continue turning in order for us to stay on the earth, whether we fall or we walk or whatever the case. That force, guys, let me take this off really quick. That force is called gravity force. There's two forces going, one towards the center and one away. The computation of that was 32 point something. Yes, ma'am? Who? Okay, yeah. 32 point something. But how many forces were working? Two. One towards the center and one away from the center. Which means what? If we only want to figure out an object falling, that means we only compensate for what? One force. So if there's a formula they came up with which was 32 point something, two forces, what is 32 divided by 2? That's where we get that 16 from. Because we only are going to be working with objects just falling in one direction, not forces pulling in both directions. Does that make sense? All right. So with that said, let's start with our first word problem, yeah? Here we go. You're like, oh yes, Mr. Q. All right, copy this. Copy this, please. Example 3. Don't copy all the verbiage at the top. Just copy the statement, the last one that reads, if you drop a water balloon, how long does it take to fall 4 feet? If you drop a water balloon, how long does it take to drop 4 feet? To fall 4 feet. All right? So, let's do a sketch, yes? And I know some of you are artistically challenged, so I'm going to do a simple one, so follow along as best you can. I know it's not going to come out as nice as mine, but try your best. Here he goes. Draw that circle, please. Then a line straight down. Oh, my hair. Sorry. There it is. Pretty good, right? Let's go. I'm telling you. Now, check this out. My height is 5'11" and a half, which is right there at 6 feet. Right? So that means that to make this one makes sense to me, because if I just stretch my arm out like this, it's about 4 feet, the drop. So we're going to label this from here to here, how many? 4 feet. Yes. All right. So, let's see what they give us in the problem. It says, if you drop a water balloon, here's the sketch, how long does it take? What does this mean? Label that T and put a question mark, because they're asking us for time. Yes. And then the fall is 4 feet, so we already have that portion right here. Okay, so look at it. They only give us 2 pieces of information. 4 feet and time. Question. Look at those 2 formulas. Talk it over to your neighbor, let them know which formula you're going to use for that simple problem. Which formula? All right, so, Noor, which one? Or what did Adrina say? Distance of time equals 16 times t squared. Yes, that is correct. Copy that, please. Oh my goodness. Okay, hold on. Let me redo this because someone said that it was a J. Okay, let me write my letters nice and neat. Alright, a little bit clearer. So let's label what we need to find. What are they asking us to find? T. We need to solve for T. However, what is this? Distance. What is the distance? No, what is, oh yeah. What is it? 4 feet. That is correct. So we write 4 equals to 16 t squared. Now, just FYI, BTW, the reason I make my t's like this, because me, Mr. Q, not you guys, me, sometimes I write pretty bad because of the tablet, not because of my writing, but the tablet that I use, and I get confused with pluses and t's. That's just me. Makes sense, right? But today I'm going to do a capital T so we don't get confused. All right, let's continue from there. We have a quadratic equation. Now we have 5 methods of solving. What are they? Graphing, square roots, factoring, completing the square, and quadratic formula. Which method would you like to use to solve this one a lot faster? Square root. Okay, so that means we need to leave t by itself, bless you. That means I need to get rid of the 16, so what do? Divide by 16, divide by 16. This is a giant 1. We're left with t squared equals to 4 over 16. And you said square root method, that means I need to do a square root. This cancels that. That leaves me with t for time. And we have, what is square root of 4? 2. What is square root of 16? 4. Now check this out. Anytime that we get a square root, we do plus minus. Is that correct? However, I'm not going to use the negative. Talk to your neighbor, let them know why I won't use a negative for that. All right. What's that? Now, if we were in the movie, and of course, the Superman would be Mr. Q. I'll be flying around the world and go backwards and make time go into the negative dimension. But we're not in the movies. There is no such thing as negative time or negative distances. It's always forward. Anyways, let's continue. So what is 2/4 simplified? 2/4 simplified is 1/2 equals t. So let's make sense out of this and answer that question in a sentence format. Look at the question. Look at what we came up with. Tell your neighbor a simple sentence that you would answer this problem with. Alright, good math talk, yes? Alright, I think Brooke's got it. What would you say, Brooke? Write that down, please. It will take half a second for the water balloon to drop Oh, 4 feet. And then at the end write 10 cubed. Alright, does that make sense? Some of you are like, 10 cubed. Let me tell you the story behind that one. Yeah?
Is that what it's face also?
Yeah, it's a little happy face with a my. Do you guys see that? Do you guys catch that on my notes? Do you guys as passes though? Anyway. I've always liked using that statement to end my word problems with, you know, because it makes it like a nice way of ending, right? And same thing when I was outside of the classroom, when I was doing trainings for different things in mathematics. I used to get teachers to go, and we'll show them new techniques and stuff. And I would end my training with this. And then time passed, and I think 10 years later, I bumped into a teacher, and she's on, Mr. Q, how are you? Da da da, good, good, good. Hug, 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 and good. So I need to ask you a question. At the end of each training, you used to write 10Q, and I was too shy to ask what it was. I was like really perplexed. And I asked my other colleagues, and nobody wanted to ask because we didn't want to seem like we didn't know our math. And I said, oh, okay. And because she didn't tell me first what it was. So you would end up with one side. I'm like, what was it? She's like, 10Q. I'm like, oh, 10Q.
Wait, what? Oh.
She waited 10 years to know what it meant. 10Q?
10Q?
Yeah, 10Q. Right, right? Anyways, from 1 to 5, I'll come through all with these. With only one object, one distance. Okay, we good. Let's move on to the next one. Copy this one. Yeah, so I'm going to scroll this up, and I just want you to copy first the sketch. Copy the sketch. It's a building with somebody on top of the building. It's 1, 2, 3, 4, 5 flights of windows. The height, the full height is 50, and then they show you a different height of 24. Give you some time for that. Copy and go. All right. So everybody drew the picture, yes? All right. Once again, I understand some of you are artistically challenged. Just try your best, okay? So here goes the situation. It reads, the rooftop of a 5-story building is 50 feet above the ground. So how tall is the building? 50 feet. Okay. How long does it take a water balloon to drop from the rooftop to pass by the 3rd-story window, which is what? 24 feet, which is high, right? Okay, so question. Out of those two heights, which is my initial height? 50, that is correct. So label that initial. And which is the new height that they want us to find, or the, you know, that they're talking about. The new height is what? 24, so I'm going to label that new. Okay, and they still want us to figure out what? How long does it take? They want us to figure out what? Time, that is correct. They still want us to figure out time. So now we have 3 things. Time, and 2 heights. So, tell your neighbor which formula out of those 2 you're going to use for this new problem. Alright? So yes, hopefully you said the second one, yes? So we're going to write h of t equals h sub 0 minus 16t squared. And just for the sake of colors, what do I use for t? I'm going to use red for time, because that's what we need to compute. And what does h sub 0 stand for? Initial, so I'm going to underline that in blue so I know what to substitute in there, which means that my new height is h of t. And all it is substitute and solve. So, what do I substitute for h of t, Miguel? Very good. 24. The one in green. Alright. Equals 2. What do I substitute for h sub 0, Miguel? 50. That is correct. Minus 16 t squared. So, which method do you want to use to solve this? Square roots, okay, so if we leave t squared by itself, we need to get rid of the 50 first, which is minus 50 minus 50. That leaves us with negative 26 equals negative 16t squared. What do I do next? Divide by negative 16. I'm left with 26 over 16 equals t squared. Since it's a square root, we take the square root. So we end up with, can we take the square root of 26? No, I just write it as square root of 26. What is square root of 16? 4. Now I'm not going to write plus minus because we're not using the minus, right? It's a distance in time. Equals 2. This cancels this. That's t. Okay. However, doesn't that look weird if you were to, if somebody's asking you, how long does it take the balloon to get to the 3rd floor? Oh, square root of 26 over 4. Really? What is that? Oh, second. Oh, my bad. Yeah, like if you're going to pull out your phone, your watch and it says, oh, square root of 26. Oh, no. Question. How can we approximate what square root of 26 is?
Oh, wait, where you get the bonus.
Oh, that's right. We need the 2 numbers, yes? 25 and 36. That's how we find the approximation. You're like, wait, didn't we do these on the warm-up? Yes. My goodness. So this should be 5 point something, yes? So let's see. What is 26 minus 25? That is 1. Over. What is 36 minus 25? That's 11. Therefore, 1 divided by 11 does not fit at a 0. Does not fit in 10. Add another 0. Does it fit into 100? Yes. 9 times. 99. And it repeats again. So this is 5.09, sorry, approximately. So I would write this as 5 point, I'm gonna round up to tenths, 5.1 divided by 4, approximately our time. Still, this doesn't make sense. What do I need to find out, or what do I need to do to find out the exact seconds? Divide. 5.1 divided by 4, it's ones. Bring down the 1 twice. I'll stop right there. So this is approximately 1.2 seconds. Am I done? No, Mr. Q, we always end with a sentence. Oh yeah, that's true. So, here goes the situation one more time. It said, how long does it take the water balloon to be dropped from the rooftop to pass by the third floor window at 24 feet? Sky to counseling at the end of class? Okay. Alright. So, how long does it take the balloon to pass by the third floor window? We found out approximately what? 1.2 seconds. So, write your statement, please. Alright, read me your statement, please, Carlos.
It takes approximately 1.2 seconds for a water balloon to fall.
It takes approximately 1.2 seconds to fall and pass by the third floor window. 10Q. From 1 to 5, how comfortable are you with these? Yeah, 5. It's all about substitution and doing your mathematics. Yes? Okay? Look at this one. Don't copy it. But look at the formula that they give you. D of t equals 8/3 t squared. What else do they give us? How long does it take the tool to fall 4 feet? So what is our distance? Where does that go here in the formula? On d of t, yes. And then the rest is history. All right, copy this next one, please. Let's go to geometry, your favorite.
Oh, yeah.
Copy the rectangle, and that information says the area of the rectangle is 60 centimeters squared. Copy that, please. All right, so for this one, they're going to ask you to solve for x, number 1, but 2, to solve for the distance in centimeters. But they want us to do it 2 ways, exact and approximately. So watch. Let's start with the formula. A equals base times height. What does A stand for? So what is the area? 60. So instead of A, we write 60. Next, instead of B for the base, what do I write? Yeah, 3x. That's the base. Times. Instead of the height, what do I write? Yeah, 2x. We multiply and then we solve. Here we go. 60 equals 3x times 2x, that's 6x squared. It's a quadratic. And we found out that the easiest to do is what? Square root. So leave x squared by itself. So what do? Divide by 6, divide by 6. We end up with 10 equals x squared. And last, take the square root, we end up with square root of 10 equals x. This answer in centimeters is exact. So if we apply it here to this one, it would be 2 square root of 10, yes? Centimeters. How about here? 3 square root of 10 centimeters. But they also want us to do approximately. So question, how can I approximate square root of 10? Tell your neighbor, please. How can we find the approximate of square root of 10? Yeah, square root of 10 is the same thing. That one is in between of square root of 9 or square root of 16. Is that correct? So that means this is approximately 3 point something. How do we find that something? We'll subtract this. That is 1 over. Subtract this. That is 7. Is that correct? Oh, in red, 7. Sorry. So that means 1 divided by 7 does not fit at a 0, fits in there once. Subtract, that's 3. Add a 0, bring that down, fits in there 4 times. And I'll stop right there. This is approximately 3.14.
That's high.
What's that?
High.
What?
Isn't that high?
No.
Yeah?
3.1415, and it continues. That's pi.
High.
You're like, really, Mr. Q? Yeah, okay, fine. It's pi. All right. So this should be a piece of pie for home friends. Bam. X is approximately 3.14 in centimeters. So what would be the approximation here? 2 times what? 3.14, which is approximately 6.28 centimeters. And over here, approximately 3 times 3.14 is 9.72 centimeters, approximately. And that's going to be the home play as well. They're going to ask you for the exact, which means leave it as a square root, and the approximate, and you know how to do the approximate. From 1 to 5, how can you with these? Yeah, just formula, substitute, and simplify. Last but not least, before we go, look up to the screen. We've been working with imaginary, and I've been bombarding you with these on the warm-ups. You don't need to write this down, but we know that square root of -1 is what? I. We also know that I squared is what? -1. So, for tonight's home play as well, you're going to get some that look like this. They're going to say, square the following imaginary and simplify. What does that mean? Then I need to take this number and square it. Which means what? 5i times 5i. What is 5 times 5? What is I times I? I squared. Am I done? No. 25 times what? -1, which is -25. Copy that or take a snapshot so you can have it as an example. That'll be our last problem for today. So, your home play is exactly what we did in class. The word problems, the 3 types, including the geometry one, and these right here. Get some extra practice over the weekend, yes? So we'll stop right there. From 1 to 5, how comfortable do you feel with all these so far? 4 5s, okay. All right. Have a good one, guys. Enjoy your weekend. See you guys till Monday. Bye. Bye.